Ladies and gentlemen, let's look at the circuit. A conductor, a metal conductor is connected to the battery. So just now we mentioned that a good conductor, let's say now we said that metal is a good conductor, right? So metal is a good conductor, but metal, a lot of metal. We have copper, we have aluminum, we have tungsten, we have constantan, we have what else? We have iron, we have lead, and so on. But what are the difference between this metal? Is it possible any metal can become a good conductor? But the difference are each of the metal also have a little bit difference in the conductivity of electricity. As we know that a good conductor is copper. Generally, we use copper as wire. Copper is not the best conductor. We choose copper as conductor is because amongst general metal, copper is better. The conductivity of electric for copper is better than others. And we choose metal is because metal is cheaper. Sorry, we chose the copper because copper is cheaper. If the best conductor of electric in this world, the best conductor of electric, you know what is that? The best one will be the gold, G-O-L-D. Okay, aurum. Aurum is the first choice. The conductivity of electricity is highest, is the best. Second will be the platinum. The second conductivity will be the platinum. And then these two types, gold and platinum, is not economically. It's very expensive. And the metal, this type of metal, not easy available. The quantity in the world are very small. But copper is more economic because it's more we are more easier to get it. It's more easier available. So we choose copper, not because copper is the best. We need to consider the economic, the economic value and so on. Okay, so now the best conductor is the gold. Where gold always used in the superconductor material. Gold also used in IC chip, microchip. So that means that a good superconductor and a good microchip or nanochip now. Okay, now the technology is already almost reached to nanochip. So that means that this nanotechnology need a lot of the aurum. Now we look at here, what will happen once the current flow through the circuit. The resistance, as we learned before, resistance is directly proportional to the length of the conductor L, and it's also inversely proportional to the cross-sectional area. This is the general for every conductor. But amongst some types of metal, we need to differentiate which one is better. So we must add in the conductivity of the material of the conductor. So at the end, the resistance is directly proportional to the length of conductor. Resistance is inversely proportional to the cross-sectional area of the conductor. And the resistance also is directly proportional to the resistivity of material. Ladies and gentlemen, what is meant by resistivity? Resistivity is the ability. What is meant by resistance? Resistance, what is the meaning of resistance? Resistance is the ability of the material to control or to limit the current. Okay, actually it's not control the current, you know. If I control the current, that means I can control it flow to this direction or that direction. I can control the value big or small, but resistance is used to limit the current. I limit the current flow in this value, that's mean like that. Okay, the words control and limit difference are if resistance is the ability of a material of a resistor to limit the current. Resistivity is the ability of an conductor to resist the current or to limit the current. That is the resistivity. So as a result, we notice that this symbol is the conductivity of electric is equal to 1 over resistivity, 1 over R actually. So at the end, we get that is equal to L over RA. So this will be conductivity. Conductivity, that means is the ability of the material to conduct the electricity. Conductivity is directly proportional to the length of the conductor. Conductivity also is inversely proportional to the cross-sectional area. The conductivity is inversely proportional to the resistance of a material. Okay. Now, we look at here. Okay. Now we look at here. A metal conductor is connected to a battery, positive and negative terminal each. So what happened? From here, V is equal to IR, and the electric field is equal to V over L, where EL equal to IR, because V equal to IR, V equal to EL. L is the length of the conductor. Okay, so from here, as substitute everything into the formula where J equal to IA, and the conductivity is equal to 1 over resistivity. So at the end, we get that the The J is equal to conductivity times with the electric field. So from here, the resistivity, okay, sorry, the J is the current density is equal to the resistivity, conductivity times with the electric field, the strength of the electric field. Now, we look at here. The equation J is equal to the conductivity times with the E, where equation NEV, J is equal to NEV, right? So rearrange everything. Okay, so this is what example. Okay, actually I want to show you, okay, the drift velocity of the, okay, if given like that. So this means that no matter how the drift velocity always less than the, okay, what's that? The original speed of the electron. So here I just want to show you the equation. NEV is equal to conductivity times with E. As a conclusion, the resistance of the conductor is directly proportional to the length of the conductor and inversely proportional to the cross-sectional area A of the conductor. The resistivity of material is given by the resistivity equal to RA over L. Resistivity is directly proportional to the resistance. Resistivity is directly proportional to the cross-sectional area and inversely proportional to the length. Next, the reciprocal of the resistivity is given as the conductivity of the material, where unit of conductivity is per ohms. How much? Per ohms per meter. And finally, the electrical conductivity is related to the current density J by the equation. The current density equal to conductivity times with the electric field strength. Ladies and gentlemen, this come to the end of our lesson, and later I'll pose you the question for today's lesson. So I want you all solve the question before you check the answer. Here are the questions I will send to you through the Telegram. So question number 1, question number 2, question number 3, question number 4, question number 5, question number 6, question number 7, and question number 8. So here's come the end of our lesson. So I end this lesson and thank you very much for attending Mr. Lee class, and see you again on next lesson.